In this module, we'll use the standard budget constraint and indifference curve setup to predict how welfare programs may affect work incentives, or the choice of how much to work. We'll rely on the model we reviewed in Module 8.1, with consumers choosing levels of a composite consumption good or overall consumption and levels of leisure. Hours of work are determined directly from leisure choices and are equal to the maximum hours available in the day minus hours of leisure. First, let's add a very simple cash welfare program to our basic model. Assume initially that the cash welfare program adds a fixed amount of benefits to supplement the income of eligible participants. For now, we'll assume that there's no benefit reduction as earnings increase. To preview, this means that benefits will provide a simple increase in income, and that should predict an increase in both consumption of goods and of leisure. Here is an initial choice of consumption and leisure. And here is the shift out in the budget constraint with the addition of this simplified welfare program. At L max, the budget constraint simply shifts directly up by the amount of the welfare benefit. And here you can see in this case that with this parallel shift out in the budget constraint, leisure hours rise or work falls. It remains the case that the size of the effect will depend on the exact shape of indifference curves and starting choices, but with standard assumptions on preferences, there is an unambiguous prediction of a reduction in work in this simple model. Here, for example, is the effect of the simple benefit model on leisure and work with one type of preference structures, or for one consumer. And here is an illustration or example for a different case, a consumer with slightly different preferences. In both cases, hours of leisure increase and hours of work decline. Next, let's modify the budget constraint to better capture the way welfare programs often work. Specifically, let's model a benefit reduction rate, so that additional work and earned income result in lower benefits from the welfare program. For now, assume that this benefit reduction rate begins with the first hour of work, or that there is no earnings disregard. This slide demonstrates the new budget constraint with this slightly more complicated welfare program, including a benefit reduction feature. At a leisure value of L max, equivalent to 0 hours of work, the budget constraint shifts out by the full amount of the benefit, as before. For comparison, the graph shows the simpler welfare budget constraint we just considered without the benefit reduction rate as the dotted blue line. With the benefit reduction rate, however, as soon as an individual begins to work and earn income, the benefit is reduced. This means that an hour of work no longer increases income by the full amount of the wage. Instead, an hour of work increases income by the wage minus the welfare benefit reduction with more earnings. Thus, in this range, the slope of the budget constraint falls to something smaller than the wage in absolute value. Eventually, as income rises enough, the welfare benefit will be reduced to 0, and at that point, shown here by the blue dot, the budget constraint returns to its original position without the welfare program. Now, let's think through the likely effects of this more complicated welfare program. It is still the case that having the welfare program raises income at any point where there's still a positive benefit amount. This should tend to increase leisure or reduce work. In addition, now, however, because of the benefit reduction rate and change in the slope of the budget constraint, participation in the welfare program also changes the trade-off between work and leisure. The benefit reduction rate lowers the effective wage and so lowers the price of leisure. This will tend to encourage leisure or reduce work. Now there's no longer ambiguity. The welfare program clearly discourages work in the range of the benefit reduction rate. The amount by which work falls in the benefit reduction range of the budget constraint will depend on the nature of individual preferences. With sharp kinks in the budget constraint, consumers will tend to have tangency points at the kink, given preferences approximating those shown here. This model summarizes the theoretical effect of welfare programs on work. What remains to be seen, of course, is what we know about the magnitude of this effect. Finally, we can also draw a budget constraint that represents a welfare program with both an earnings disregard and a benefit reduction rate. That model is shown here. Results with this model will be similar, with the income increase from the benefits encouraging more leisure and the fall in the effective wage rate from the benefit reduction rate reinforcing this incentive. This model provides the theoretical basis for concerns that many safety net programs can have negative work incentive effects. Recall that TANF, for example, is structured in a similar way to this model, as was AFDC before it. with a maximum benefit and earnings disregard amount, and then a benefit reduction rate. Nationally, the benefit reduction rate in TANF is quite high, averaging approximately 61%. In California, the rate is slightly lower than average at 50%. Finally, SNAP nutrition benefits also reduce benefits as earnings rise. With this background in the relevant economic theory, in the next module, we'll look a bit at what we know about how large these work disincentives seem to be. As with many predictions from economic theory, the magnitude of the response to the incentives may be a critical part of making informed policy choices.